Okay, hi, welcome to Logs Lesson 5. This time we're going to be looking at solving disguised quadratics. Two types. Firstly, we're looking at things like this, where you've got e to some power, and then there's one more level of disguised nature where instead of e we have some numbers in here, and it just makes it a little harder to spot. But we'll have a look at those in a moment. First of all, how on earth are we to know whether this is a quadratic? I mean, it's clearly not a quadratic, but it has a lot of properties like quadratics. The first thing you want to be looking out for is in the power, you want to be hopefully noticing this 2x and x. And again over here, 2x and x. This is where we essentially get our variable squared and our variable, so y squared, y, or x squared and x. So what we want to do here is treat this e to the x as a variable in its own right. Okay. So sometimes you might be given a hint using y equals e to the x. Sometimes you may not be given this at all. So first of all, let's replace e to the x with y. So every time there's an e to the x, here we're going to have minus 6y. Here, we're going to want to write it a little bit differently. Okay, so here, none of that's changed. That's all exactly the same equation. The only thing we're going to do a little bit differently is this. Let's write this as e to the x all squared using our rules of indices. These two things are the same. So now we can do our substitution. And here we're going to get y squared. Here we're going to get 6y. And here 5 and the 0 don't change. All we now have to do is, no, that's not quite true. We now have to solve this quadratic. You can do that. This one's easily factorizable, but they won't always be. We're going to get two values for y. But because y is e to the x, we can therefore conclude that e to the x is equal to 5 or e to the x is equal to 1. Now we need to use logarithms to solve those two simple equations. Okay, you could, like I've done, take logarithms of both sides, or, sorry, ignore what I'm saying, that's the way to do it. Just take natural logarithms of both sides, because they're inverse functions, they're going to cancel out, so we're going to be left with x on this side and ln 5 on this side, and same again here. Now ln 1 is just equal to 0, so we can simplify that. Pause the video, have a go at the next question, and see what you can do. The answer is as follows. So here, we're going to move everything across, because we've noticed this 2x and the x, move everything across to the left-hand side. We know it's going to be a quadratic, or disguised quadratic. We're going to substitute in our y for e to the x, solve the quadratic equation, and then put e to the x back into instead of y, and use logarithms to solve. Now remember, e to the x does not ever give you a negative value. If we draw a little sketch, e to the x looks like this. So there is no value of x for which we ever get a negative result. And so in this case, this is impossible, meaning we've only got one solution to this. Okay. So there's one more level that we could complicate this a little further. Let's have a look at these. So now you'll notice instead of e, we've got a number, but that's fine. E is just a number. It's just an irrational number. But here we're going to use an integer. But you'll notice now that the exponent doesn't have a y and a 2y. It's just y. But nonetheless, there is hiding in here a quadratic. If we're going to solve this, we're going to need to kind of somehow change these two bits here, 25y and 5y, into something that's a bit more similar. And hopefully you've noticed already that 25 is 5 squared. If we make that change, we now are starting to get somewhere towards a quadratic equation. So instead of 25 to the power y, we've got 5 squared to the power y. The rest of this equation remains unchanged. But now we have, essentially, this is our variable squared. We can rewrite that part there as 5 to the power y squared, again using our rules of indices. So let's keep the rest of that the same, and now we can make some sort of substitution. It's worth writing this down in any solution that you give. Okay, the question doesn't mention x, so we need to define what we're allowing x to be. Okay, and then we can make our substitution, solve the quadratic equation to give us two values of x, and now we're able to substitute 5 to the power y back into these. So we're going to get two equations that we now need to solve to find the correct values of y. Two different ways of doing it, and I want to just highlight them both because you need to understand them both. The first way, we can just jump straight to the solution using definitions of logs. That's what logs were created for, to be able to solve problems like this. What power do I raise 5 to get 3? This is the power that I raise 5 to get 3. And that's as simple as that. Type that into your calculator if you need a decimal approximation, and you've got your answer. But there are other ways of solving it, and it's worth being aware of them. What if we take natural logarithms of both sides of that equation? So we're going to have ln of 5 to the power y and ln of 3. We can now use our power rule to rewrite the left-hand side as y times ln 5 equals ln 3. And that gives us y equals ln 3 over ln 5. If you type those two expressions into your calculator, you'll get exactly the same value. And this gives rise to something called the change of base formula that you may have come across in the Khan Academy videos. I'll mention that a bit more in a moment. Let me give you another example. So here we have the equation that we need to solve to finish this problem off. We could use just the basic definition of logarithms. The power that I have to raise 5 to get 4 is log base 5 of 4. Or we can take natural logarithms or any logarithm to any base of both sides, use the power rule, and divide by log 5. That's right, log 5. Pause the video, have a go at the next question. I encourage you to use both methods at the bottom there to get the two different answers so that you're familiar with them both. After you. Okay, and the answer is as follows. You'll notice here again we've got a possible solution. 3 to the power t can never be negative 3. So we've only got one solution. And here I've used the natural logarithms and just the definitions of what logs are. Finally then, the change of base formula, which comes from that example, is this, that if I've got log to the base b of some number a, that's the same as log to any base of a divided by a log of the same base of b. So for example, we could have ln a over ln b, or log a over log b. You get the idea. Have a go at exercise 7D. Try all the questions. Remember, this takes time to get confidence, familiar with all of this. But I think you should be fine. Take care.